Okay, let's multiply some polynomials. If you will find your 3x4 piece of paper that we folded in class, that is titled Unit 2, Day 2, Multiplying Polynomials. Write down this learning objective real quickly. Simplify polynomials using multiplication. And then take a moment to copy down these three problems in the first row of your 3x4 fold. These are review problems. This is what we did in Unit 1. I want to real quickly go through how we can do these. If you look at your first example here, notice that there are no pluses or minuses. This is one term. Even though there's a dot in the middle, there's no pluses or minuses. This is all one big multiplication clump. That allows us to rearrange this in any order that we want. So 6 times 3 gives us 18. Y to the third times y to the fifth. We add those exponents, we get y to the eighth. In the second example, they have two sets of parentheses. That may make you think that there are two separate terms here, but notice there are no pluses and no subtractions. This is just one big multiplication clump, which means we can drop those parentheses and rearrange that in any order that we want to. Okay, so what we have here is 3 times 9, 27. N times n squared is n to the third, and n squared times n is n to the third. Lastly, we have 3 different sets of parentheses here. There are no pluses or minuses. Once again, since it's all multiplication, we can rearrange this in any order that we want. So the numbers, the fraction and the negative 12 come up to the front. Then your S's. Then your T's. Okay. 1/4 of negative 12. Remember that if you want to multiply two numbers, and one of them is a fraction, one of them is not, just make them both into fractions. Then you can just multiply right across. Okay, well, 1 times negative 12 is negative 12. 4 times 1 is 4. You can see that negative 12 divided by 4 is just negative 3. Then we have s to the second. First and first, that's 2 plus 1 plus 1. That's s to the fourth. Then we have t squared times t to the first times t squared. That's t to the fifth. Take a moment to copy down the 3 problems you see here on the bottom and try those on your own. Then start the video back up again and see how you do. Okay, let's see how you did. Three x to the third times 6x squared. I can rearrange that anywhere I want. I should get 18x to the fifth. 2r squared t times 5t to the third. You can rearrange that in the order that you want. That gives me 10r squared t to the fourth. Lastly, I can rearrange these pieces any way I want to. It's all one big multiplication clump. Okay. 1/3 of 12 is 4. X squared times x to the third is x to the fifth. Then we have y to the first times y squared times y to the fourth. That's y to the seventh. And z to the fifth. Okay. Now that's the only review that we did in day 1. What I'm about to show you down here at the bottom is review mixed in with some new stuff. In other words, take a look at these 3 expressions here. Take a moment to copy them down. And notice that we're multiplying a monomial here times a polynomial. When we do this, we'll utilize distributive property. So in the first example here, we'll distribute that 4 to each one of the 3 terms. Remember that 4 is only going to affect the normal numbers. So 4 times 3x squared is 12x squared. Middle term will be 4 times 4, 16x. And then lastly, minus 32. As we box this answer up, notice that none of those terms are like terms. So we're simplified. In the second example, it's a little bit more complicated. We have 6pq times pq minus q. So in the first part of the distributive property, what we might call the hippity, we'll be responsible for 6pq times 2p. In the second part of the distributive property, which your teachers in the past might have called hoppity, right? Hippity, hoppity, distributive property. Then you'll be responsible for 6pq times negative q. All right, let's take a look at each one of these 2 expressions. Here I can rearrange this order any way I want to. I end up with 12p squared q. Here I've got 6 times a negative 1 in the front, so 6 times negative 1 times p times q times q. This ends up giving me a negative 6, so I'll subtract that term, p q squared. Now notice that even though these guys are very similar, that squared is in a different spot. We have a p squared q and a pq squared. These are not like terms. Therefore, I can box up that answer and be done with it. Lastly, here I have a term 1/2 x squared y, and I want to distribute that to the 6xy and the 8x squared y squared. So let's do so. Okay, so in the first one here, I have 1/2 x squared y times 6xy. In the second one, I have 1/2 x squared y times 8x squared y squared. Okay, let's see what we got. Half of 6 is 3, x to the 3rd y squared. Okay, half of 8 is 4. It's a positive 4, so we'll add it. X squared times x squared is x to the 4th. And then lastly, I'll have y to the 1st times y squared, which is y to the 3rd. Okay, these are not like terms. I can box it up and be done with it. Okay, take a look at the next 3 examples. Work these on your own, and I'll work them for you in a moment. There we go. I distribute the 2 to all 3 of those terms. The 2 only affects the normal numbers. So 2 times 4 is 8, 2 times 1 is 2, and 2 times 3 is 6. Second example. Okay. Last example. Okay. Now notice on this green part, I have 5 times negative 3 that gives me a negative, so minus 15. Okay. These may look very similar terms, almost like terms, but they're not, which means we can't go any further, and we are done. Okay. Make sure this is filled out. You bring it to class next time I see you. Have a good one.